Hello everyone. So today we'll be learning about one concept from chapter 2 of SRM, which is the partial correlation, which we have in case of multiple linear model. What is multiple linear model? Multiple linear model is when your response variable depends on more than one explanatory variable. In the context of that, what do we mean by partial correlation? So partial correlation between the response variable y and the jth predictor xj, any response variable y and the jth predictor xj, is the correlation that we have after controlling for the effects of the remaining predictors. What do we mean? Let's see the steps. So ideally, when you have correlation between two things, let's say you have the response variable y and you have only three things, three predictors. Let's say we call them x1, x2 and x3. These are your predictors and this is your response variable. Now, when you go for calculating the correlation between y comma, let's say x2, this may be anything, right? This can be, let's say, 0.9. Maybe it's very highly correlated. But why don't we call it partial correlation? And how is partial correlation different? That is what we want to know. So point is, when we calculate the correlation between y and x2, it's not only showing us what is the correlation between y and x2 alone. So x2 may contain some information from the other variables. What were the two other variables? We had x1 and x3 as well, right? So there may be some correlation between among these predictors. What do I mean by that? X2 may be containing information of x1 and x3. Hence, this correlation is not actually showing you what is the relation of y and x2 alone, because x2 in itself contains some amount of x1 and x3. Now, if we want to calculate the relation between pure x2 and pure y, then what are the steps that we follow? The steps are, we first regress our explanatory variable y on all other predictors except the predictor that we want to calculate the partial correlation with. So in my case, when I was trying to calculate, let's say instead of correlation, if I want to calculate the partial correlation between y and x2, what will be the steps? The steps would be, first, number one, we'll regress y on x1 comma x3. Once we regress this, we get some error, let's say E1. These are the residuals. What do we mean by these residuals? We mean that it's the part of y which could not be explained by x1 and x3. Next step, we regress x2 on x1 and x3. Let's say we get the residuals. So these are the residuals from these two regressions. E1 is the residual from linear regression of y on x1, x3, and E2 is the residual when we regress x2 on x1 and x3. So to make it easier, think of it as pure y. Think of it as pure x2. So whatever was the effect of x1 and x3, those have been removed. Whatever was the effect of x1 and x3, those have been removed from x2. That means what is left is only pure x2. So these residuals are representing the pure x2. These residuals in the first model, they represent pure y, which is not containing any info from x1, x3. Now, if we regress, third step would be regression of E1 on E2. So it's a simple linear regression. Now, this would give us some beta hat, basically the slope coefficient. This is called the partial correlation. So this basically shows the actual correlation between y and x2. So it's just the pure components that we have. Let's read it again. Now, if we read the definition, the partial correlation between the response variable y and the jth predictor xj is the correlation after we control for the linear effects of the remaining predictors. Specifically, these are the three steps which I explained you already. Notation wise, here they call the partial correlation to be the correlation between E1 and E2. Okay, I'm sorry, this is not beta hat. This is the correlation that we call partial correlation. So here, when you have E1 and E2, then you can calculate the correlation between these two. That's what you call partial correlation. Okay, not the betas. Sorry. So yeah, that's about partial correlation. I hope it was clear to you. Thank you.